My dear students, in our previous video, we have started the topic applications of vector algebra for 12th standard mathematics students. So this topic is more useful for both CBSE students and state board syllabus students and matriculations also. This topic applications of vector algebra is a common topic for all the streams of students. Now, in this video, I am going to introduce the properties of dot product. Yesterday, we have defined the dot product of two vectors and what is the angle between the two vectors and how to find out the dot product of the two vectors A and B. Now, and also we have started some properties of the dot product in the previous video itself. And we have seen in our video dot product of equal vectors we have seen yesterday. That is, dot product of equal vectors A dot A is equal to, mod A into angle between the vectors A, same vector A into A, same vector, there is no angle, cos 0. This is 1 into A, you get A square, A vector square, or it is expressed as A square. This is we have seen already in our previous video. Now I am going to introduce the dot product of I, J, K unit vectors acting along the coordinate axis system. That is our property 5. Dot product of I cap, J cap and K cap. Dot product of I, J, K unit vectors acting along the coordinate axis. Acting along the coordinate axis. That is our property. This is a three-dimensional coordinate system. This is our origin. This is x-axis, y-axis, and z-axis. In the x-axis, you will get the unit vector I cap. In the direction of y-axis, you will get the unit vector j cap. And in the direction of y z vector, you get the unit vector k cap. Now we have to find out the dot product of I, J, K unit vectors. These I, J, K are unit vectors, and these to be find out in the counterclockwise direction. First, I dot j, I cap dot j cap equal to, mod of I and mod of j cap into cos angle between I and j is 90 degree because I am mutually perpendicular axis. This is coordinate system. Angle between I and j is 90 degree. Cos 90. Cos 90 is 0. This is mod of unit is 1. Modulus of j is 1. Cos 90 is 0. Therefore, entire multiplication is 0. Therefore, I cap dot j cap equal to 0. Because cos 90 is 0. Okay. Similarly, j dot k. Say j and k are perpendicular, therefore j dot k is also 0. Already, if the two vectors are perpendicular, the dot product is 0. We have seen. So I dot k 0, j dot k 0, and k dot I. K dot I is also 0 because k and I are perpendicular. K dot I is also 0. Our dot product is commutative, therefore I dot j is also equal to j dot I. I dot j 0 implies j dot I is also 0. J and I are also perpendicular. And dot product is commutative, Similarly, j dot k 0 implies k dot j is also 0. And I dot k is also 0. So, that's all about the dot product of the opposite vector, I take k, I dot j 0, j dot k 0, k dot I 0. Similarly, the reverse direction is also 0 because dot product is commutative. Next, I am going to see the dot product of same vectors. Okay? Next, the dot product of I dot I, same vector, like this. I dot I. So I dot I is unit vector, mod of I square, you know. Mod I square is, mod I is 1, therefore 1 square is 1. 1 square, that is 1. I square, 1. So I dot I is 1. Similarly, j dot j is also 1. K dot k is also 1. This is the dot product of the same vectors. I dot I, j dot j, k dot k are unit vectors because the dot product is 1. Next property number 6 is, if m is any scalar, A and B are any two vectors, then ma dot b vector equal to A dot mb vector equal to m into A dot b vector. So, m is any scalar and A and B are any two vectors. That m scalar can be associated either with A or with B or common A dot B. So, ma dot b is also same as A dot mb, and it is nothing but it is equal to m into A dot b. So, the scalar m can be associated with the vector A and b like this. This is our property 6. Next, our property 7 is, listen, property 7, that is m and n are any two scalars next property m and n, seventh property. If m and n are any two scalars, then A and B are into vectors, ma vector dot na vector, ma vector dot na vector equal to mn into A dot b, mn into A dot b. It's also equal to mn into A dot b or A dot mn into b. So that product mn can be associated like this. These are the cases, all the values are equal if m and n are both scalars, and A dot b can be expressed like this. These values are all equal. This is our property 7. Okay. Next property, the scalar product is distributive over addition. That is, scalar product or dot product is distributive over addition. That is, A dot b plus c equal to b plus c vector equal to A dot b plus A dot c. That is your distributive law, where A, B and C are any three vectors, where A, B and C are any three vectors. For any three vectors A, B and C, the distributive law A dot B plus C is A dot B plus A dot C. A is distributive over addition of these two vectors B and C. Next, for any two vectors A and B, next property, for any two vectors A and B, A plus B, A vector plus B vector the whole square. A vector plus B vector the whole square equal to A vector plus B vector the whole square equal to A square plus 2 into A dot B plus B vector square. This is our result. If a vector plus b vector whole square equal to a square plus 2 into a dot b plus b square. How we can prove this as a plus b vector whole square is equal to a plus b dot a plus b. You know dot product is distributive. According to our previous law, a should be operated with a dot a plus a dot b. Similarly, b dot a plus b dot b. So a plus b whole square is nothing but a dot a plus vector plus b vector dot a vector plus b vector. That is by distributive law a dot a plus a dot b plus b dot a plus b dot b. That's our idea. A dot a, you know, a square. A dot b and b dot a are equal. A dot b. B dot a is also a dot b. You know, dot product is commutative. Therefore, this is 2 times of a dot b. Because a dot b and b dot a are equal. Plus b dot b is b square. That's all about the result. Similarly, I can write another result. A vector minus b vector the whole square is a vector square minus 2 into a dot b plus b vector square, as in the case of algebraic results. A vector minus b vector whole square equal to a square minus 2 into a dot b plus b square. Okay? That result is a vector plus b vector dot a vector minus b vector. This is again by distributive law, it is a square minus b square. As in the case of algebra result, a plus b into a minus b equal to a square minus b square. Like that, the vector product is also a vector plus b vector dot a vector minus b vector is equal to a vector square minus b vector square. That is a square minus b square. And one more result, a vector plus b vector plus c vector whole square. This is equal to a square plus b square plus c square plus 2 times of a dot b plus b dot c plus c dot t. You remember this also algebraic expression, and it is also true for vector also. Okay, next property, scalar product in terms of its components. Scalar product in terms of components. Scalar product in terms of components. That is, suppose a vector is given by a1i plus a2j plus a3k, and b vector is given by b1i plus b2j plus b3k. A vector is given by a1i plus a2j plus a3k, and b vector is given by b1i plus b2j plus b3k. Now a dot b, a vector dot b vector equal to a1i plus a2j plus a3k dot b1i plus b2j plus b3k. You know by dot product definition, I dot I is 1. You know I dot I is 1, therefore a1 into b1. First term. And second time I dot j is 0, therefore a1 b2 is into 0. I dot k is also 0, so a1 b3 is also 0. So just I dot I is 1, then you will get only a1 b1. Similarly, j dot j is 1, therefore you get a2 b2. And j dot I and j dot k are 0. Similarly, k dot I0, k dot J0, you get only k dot k is 1, therefore A3, B3. So A dot B equal to A1, B1 plus A2, B2 plus A3, B3. This is your expression. Dot product of two vectors with its components is given. Okay. For example, I am going to solve one sum. If say A vector equal to I minus 2j plus k, I vector, I minus 2j vector plus k vector, and B vector is given as 4i minus 4j, 4i minus 4j plus 7k. Now dot product of these two vectors A dot B, as in the previous case, A vector is I cap minus 2j plus k, dot B vector is 4i minus 4j plus 7k. So by taking dot product, you know, I dot I1, so 1 into 4, 4, minus into minus plus, j dot j is 1. So I dot I1, j dot j only you consider minus to minus plus sign, j dot j1, 2, 4, sorry, 8, k dot k1, 1 into 7, 7. So your answer is 19. So A dot B equal to 19, which is a scalar, therefore it is called a scalar product. Okay? Now, the 11th property, angle between the two vectors A and B. We know that A dot B equal to mod of A into modulus of B into cos theta. From this, you bring A dot B by mod A into mod B to the left hand side. It becomes A dot B by mod of A into mod of B equal to cos theta. So this is the formula for finding the angle between the two vectors A and B. So cos theta equal to A dot B by mod A mod B, or otherwise theta equal to cos inverse of A dot B by mod A into mod B. This is the formula for finding cos theta equal to A dot B by mod A into mod B, or theta equal to cos inverse of A dot B by mod A mod B. This is the formula for finding the angle between the two vectors A and B. Now we will consider this example. Find the angle between the vectors A vector is I minus j and B vector is j minus k. So you know the formula for finding the angle between the vectors, cos theta equal to A dot B by mod A into mod B. Okay. So that is cos theta equal to A. What is A? I minus j dot B, j minus k by mod A. Mod A is mod of I minus j into mod B is mod of j minus k. So that is equal to I dot j 0, I dot k 0, minus j dot j 1, minus 1, minus into minus plus j dot k 0. So minus into plus minus, j dot j only 1, you will get in the numerator. Mod of I is, you know, magnitude of the vector is 1 square plus 1 square. It is also 1 square plus 1 square, coefficients of j and k. This is minus 1 by root 2 into root 2. This is equal to minus 1 by 2. So cos theta equal to minus 1 by 2. This implies, what is theta? Theta is, cos theta is negative in the second quadrant. Therefore, this is 90 plus cos of 2 pi by 3, 120. Cos 120 equal to this is theta is 2 pi by 3, you know, because cos 120 is minus 1 by 2. How? You know, this is our answer, angle between the two vectors is This is theta equal to minus 2 pi by 3. Okay, how this is cos 2 pi by 3 is cos 120 equal to cos 90 plus 30. 90, change the cos into sine. Second quadrant cos negative, so minus sine 30, that is equal to minus 1 by 2. So cos 120 is minus 1 by 2, therefore theta is 120 or 2 pi by 3. Because 2 pi by 3 is 120 degree. So this is the angle between the vectors I minus j and j minus k. So this is for our reference I have solved. You can write straight away cos theta equal to minus 1 by 2, it implies that theta is 2 pi by 3. So that's all about the problem. Now I am stop my video here. Listen, these problems are very very important for both state board syllabus and in the CBSE students also. So you take care of these videos and make use of my lessons and subscribe my channel, and so that you can get our further videos regularly. Subscribe my channel and press the bell button. Okay, thank you.